Hello, you are now listening to the Modem Podcast, where we deconstruct, examine, and discuss deeply technical data networking and information technology topics. Sit back and relax while we fire up Dial D and the 9600 baud modem and connect to the Wildcat BBS.
Hello and welcome to the first episode of Season 2 of the Modem Podcast. I'm going to guide you all through this episode today and this fresh season, fresh start, new year, all that fun stuff. Today, we're talking about something else that's actually really fresh and exciting. It's a new tool that Pepelnjak has created called netsim-tools. Now, us here at Modem are no strangers to doing a little bit of network labbing. I'm a firm believer that it's one of the best ways to actually get your hands on things and understand a protocol, understand a network operating system, and just really, try out changes before you roll them out to the real lab, which is production. So we're going to talk about this tool, netsim-tools. Long story short, it's an alternative to a GUI-based lab tool and CLI-centric, and it sounds pretty exciting. I'm a big fan of not clicking in GUIs all day. So Ivan, I'll hand it over to you and let you introduce yourself real quick.
Hi, I'm Ivan. I've been running ipspace.net for, a decade and a half or something. Started as a network engineer way too long ago when IPX and AppleTalk were still a thing, and you were happy if you got a frame relay line. Then semi-retired in the meantime, got bored, got back into networking, figured out that nothing has changed, and that's been my shtick for the last 10 years.
Very good, very good. And here to make sure that our grumpy pants are freshly laundered and kept in stock is Nick Buraglio.
When did I become the grumpy old guy?
When did I become the grumpy old guy? Before you know it, you wake up one morning and you have a fresh pair of grumpy pants on.
I know, and I don't want any kids on my lawn. Anyway, I'm Nick Buraglio. I'm the co-host, and everyone probably knows me and probably wishes they didn't.
Can confirm. So, going into the tool a bit, Ivan, how about you tell us a little bit about kind of the motivation behind building netsim-tools, and maybe just give us a brief overview, kind of the 20,000 feet view of what it does.
Well, as you mentioned, a lot of the network labbing tools, the ones that work with virtual machines behind the scenes, have a GUI front end, and I always hated that. I want to build a new lab, and now I will chase the mouse around for an hour trying to get the links in just the right place. In the meantime, the server people and the developers are running circles around us with YAML files and things like Terraform or Vagrant. And they spin up new stuff in 3 minutes, which is the time I need to warm up the mouse. So I wanted to have something that would be text-based so that I could do copy-paste and build my topology. And ignoring for the moment the stupidities of not having downloadable images from the vendors and having to go through the rag wall and building your own Vagrant boxes. In the end, you set up things and you have your Vagrant boxes, and then you spend, I don't know how long, with some arcane thingy called Ruby. And once you master that syntax and you do Vagrant up, bam, your lab is up and running and you're a happy panda. Unfortunately, that Vagrant file gets ridiculously complex the moment you have more than one network. And there were people solving that with a nice tool that would take the graph description. There's this graph description language, dot, and they would transform dot into Vagrant files. So based on the links in the graph, they would actually build the networks in the Vagrant file. And that's cool, but obviously that thing is aiming at something else. It has a slightly different, let's call it that way, syntax. And it's really hard to specify attributes like amount of memory or how many CPUs you want to have or anything like that. So it all started with me wanting to have something where I could say, I have these 5 nodes, and 3 of them are this Vagrant box, and 2 of them are this other Vagrant box, and there are these links between them, and go build me the lab. That was like release 0.1. And I just managed to set up my Intel NUC. So it was all Linux-based with libvirt. And later I added the VirtualBox support. Don't get me into how broken VirtualBox is with Vagrant. That would be a totally other podcast. And so I had this nice tool where you could say, well, I have these nodes, I have these links, build me the lab. Now, you know that when you stop chasing GUI and all the nodes are up and running, you're like 10% done. You spend the next 3 hours logging into the boxes and typing in IP addresses. And what happens next is, of course, that you do copy-paste from your Excel spreadsheet wrong, and then you have subnet mismatches, and you spend the next 2 hours chasing subnet mismatches. So why don't we have a tool that would solve that stupid, irrelevant, totally, bogus problem and just assign subnets from some address pool to the interfaces and assign node addresses based on node IDs or upper lower on /30 links and be done with it. And that was like the second thingy I got into that tool. Now, once you have the nodes up and running and you have the addressing plan somewhere in a YAML file, now obviously you need the glue, the configuration templates that would push the addresses onto the nodes. So you take, the default configurations that come with Vagrant boxes, however you want to build your boxes. And then you need something to push the configurations with interfaces and IP addresses that you built onto those boxes. Now, as much as I hate Ansible, it's the best tool for the job. I mean, I'm sorry to admit that, but Ansible is the best tool for that job, particularly because it has modules for every crappy device out there. So I knew that if someone would come along saying, I want to have a Microtik box, and well, by the way, someone did, then we would be able to handle that with Ansible. So I wrote a bunch of Ansible playbooks that would deploy the configs based on configuration templates. So at that step, I had IPv4 addressing set up. What's the next stupid thing you have to do? You have to log into all those boxes and you have to type router BGP blah. And then you have to type neighbor blah blah, update source loopback 0, neighbor blah blah, description, neighbor blah blah, activate, neighbor blah blah, blah 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 blah. And of course, you mess up the neighbor addresses and then you go into another round of troubleshooting, trying to figure out why the BGP sessions are not up. So that was the next iteration. I added configuration modules where you could say, well, I'm running OSPF. And the tool would figure out that, he wants to run OSPF, so let's figure out which links are connections between the routers. And just enable OSPF on those links. And then I would add, little things like you could set OSPF areas, or you could set OSPF cost on a link, or on a one node on link if you want to have asymmetrical costs for whatever stupid reason, like you want to test how broken stuff is. And then for BGP, so OSPF was a piece of cake, ISIS was a piece of cake, EIGRP is a piece of cake. For BGP, I really went as far as when you assign nodes to autonomous systems, then I would automatically figure out which eBGP sessions you need based on the underlying physical lab topology. And then if you would specify route reflectors in an autonomous system, you would get, the star, all route reflectors to all clients, N stars actually, because you could have more than one route reflector. Or if you wouldn't specify the route reflectors, you would just guess a full mesh of iBGP sessions. So you would just say, well, I want this lab and it needs to run OSPF and it needs to run BGP, and these 5 nodes are in this autonomous system and these 3 other nodes are in this autonomous system, and these are the links, and bam, you have a running network.
So I think it's fair to say then that it's more than just a, virtualization, tool that guides you in spinning up, a bunch of VMs and then says, here you go, have fun. It also has the ability to declare not just your topology, but also declare your configuration and then render that configuration, take that intent basically as configuration out of the devices and actually, have you at a nice starting point.
Well, yeah, it's an intent-based lab, yeah.
So
Nice.
I want to circle back to something that is a particularly thorny pain point for me. And you kind of just said it in like one sentence, like it was easy, which is to kind of how you do a lot of things, Yvonne. You just do
Sorry
this
about
because,
that.
you're just very smart. So, it's easy to do that. But like the IP addressing pieces are the bits of any lab that I dread more than anything else, because after about 2 devices, everything looks the same to me, and I will inevitably misconfigure. I mean, it's a foregone conclusion that I will misconfigure after the second box is done. It will just be wrong after that. Every single time I do it, no matter what I do, if I cut and paste, it doesn't matter. It's still going to be wrong. And you've got a mechanism for saying, here's a pool of addresses. So you essentially built a makeshift IPAM.
Exactly.
Man, that's really nice, because that's the most time consuming part for a lot of people, I think, especially if you're dual stacking.
So effectively what you have is 3 standard pools for LAN links, for stub links. LAN link is multi-access link with routers on it. Stub links is what is attached to a router just to have a prefix. Then you have point-to-point links, and then you have the loopbacks. And as the tool is going through the links, it just figures out what link type this is, and then it goes into the address pool and grabs the next available prefix from the pool. You can specify the prefixes for all pools, and you can also specify the pool size and the subnet mask for individual prefix. So you don't have to work with /24s. You can have whatever you wish. On IPv6, I try to stay on /64s to be a good citizen, but if you want to break stuff, you're allowed to break stuff. And then you can define custom pools. So if you want to have, core links are like this, and edge links are like this, and inter-AS links are like that, you can have that. So you can define as many pools as you wish, and then you just say, well, this link is an edge link, and it goes and takes the prefix from the right pool for both IPv4 and IPv6. There's even provision for unnumbered IPv4 and link local only IPv6. And then for the point-to-point links, usually it's a /30 or a /64 for IPv6. And for IPv4, I would take the, first and the second address from the prefix, and this happens to be the lowest and the highest one due to the prefix length. For IPv6, I think it's also .1 and .2. For anything else, the node has a consistent node ID, and on every other prefix, I use that same node ID. So the third node in your list will have the loopback 10003, and on every LAN link, it would have the prefix, let's say 172.16.1.3, 172.16.2.3, and so on. Now, obviously, I love nerd knobs like every other networking engineer, so you can specify the prefix for the link on the link if you wish to, and you can even specify static IP addresses for the nodes on the link if you really wish to. So I give you as much rope as you need to hang yourself and break the network.
That's the mark of a good tool right there, right? A flexible tool that'll be useful. I don't know. I guess I'd be kind of beating a dead horse at this point, but I love to lab just like Chris does, just like every network engineer does. And I spend the majority of my work time doing that kind of thing. And the IP address management is without question the part of it that I will procrastinate doing everything else before I will do that piece.
Yeah, I think to me, it sounds like the theme of the tool is really, getting rid of the monotony of labbing and letting you get to the actual fun stuff. Because I remember when I first started labbing, eons ago, well, not eons, but a while ago, I thought it was kind of fun to come up with an IP scheme, and I remember doing the same thing where I was like, oh yeah, 10.003 is node 3. And I did that once for a lab, and it was really great, and I had a good time doing that. And then I never wanted to do that again because it's not fun. And when you have to change the topology, keeping track of all of those and what was my methodology? I mean, I'm I'm really bad at details in the first place. So like for me to try to keep all that in track is just a nightmare. And so, yeah, I think, as a beginning network engineer, yeah, maybe you do want to do that the first time so you can understand what works and what doesn't. But then once you kind of figure that out, use this and no longer have to think about it. Because I think, well, as a network engineer, what I focus on is, the interesting stuff like the protocols and, the services that we're delivering and all that fun stuff. And this isn't the interesting stuff. Like figuring out what IP addresses, figuring how do you turn up BGP? Like turning up BGP is easy. Like it's just a chore. I love the idea of getting rid of chores because I hate chores.
That's exactly the point. And, I always have to go one step further because once you set up BGP, you want to set up, DMZ bandwidth, or you want to set up the add path. And when you do it the third time, it's a chore. So what I did first was I added custom configuration templates where you could just say, well, on these nodes, on top of what you already did, now deploy BGP DMZ bandwidth, or deploy BGP add path, or deploy OSPF, whatever. And then I figured out that sometimes I have to calculate stuff that would be possible to do in Jinja 2 template, but I wouldn't want to do it. So I wrote a whole system of plugins where you can combine Python code with your config template. And then the Python code has like a gazillion hooks that are called if you define them before the topology is initialized, before the transformation starts, globally after the transformation has been done, for every link, for every node before and after the transformation. So you can look at before or after values, whatever you need. You can calculate anything you wish. You can modify the data model in any way you wish. And then all that gets written into an Ansible inventory. And then your config template can just grab those bits and pieces that you carefully put together in your Python code and configure your stuff. And the cherry on the cake is a bit of packaging where you can put the config templates that are named after the operating system and the Python code in the same directory. And then you just say, I want to use this plugin. And then the Python code is involved to calculate stuff. And during configuration deployment, the proper template for every single device is invoked so that you can configure multi-vendor network like Arista plus Cisco plus Juniper plus whatever. And so you can build, your Lego bricks yourself, and you never ever have to configure add path again once you spend some time writing that template.
That's very cool. And so these configuration modules now, like you mentioned, you can write your own, but there's also a bunch that are included. You want to maybe go into which ones are included by default? I know you mentioned BGP and some link state protocols.
Yeah, well, it's all the major routing protocols, OSPF, ISIS, EIGRP, BGP, and segment routing with MPLS.
Nice.
I will probably add MPLS with LDP in a few days. That one is, a low-hanging fruit. That's really easy. I will eventually, no promises when, add VLANs and VRFs. And once you have VLANs and VRFs, then you can go into MPLS VPN and EVPN. But right now, honestly, I'm struggling with the data model. How do I... Because, I always want to have a data model that is network, not device-centric. It would be really easy to just say, well, on this interface, I will have VLANs 1, 2, 3, and that gets translated directly into the configuration. And then you have duplicate data because you mentioned the same VLAN on all devices, and you get a typo and happy troubleshooting. So I want to get beyond that.
And also every vendor has their own way of doing, those standards-based protocols. Like so EVPN is a great example. Like it's a little bit, the flavor is a little bit different on every vendor's box. And so you have to build this protocol specific model as well. That's a bit more vague and a little bit different how Juniper does it, a little bit different how Cisco does it, a little bit different how so-and-so does it. I mean, even with the SRMPLS stuff, I could see, building that model could have some not problems, but some difficulties because when it comes with like figuring out where your label space comes from, the global space is different on some platforms. So that's a lot of effort, like thinking through, basically the lowest common denominator, I suppose, of what features are supported to be able to model those? Has that been kind of a struggle that you've had to deal with while developing these?
Well, OSPF, the IGPs and BGP were relatively easy. Segment routing turns out is really easy until you go into the complex stuff like traffic engineering with segment routing or LFA. And IETF took care of remapping label spaces between nodes. So they added this totally convoluted, complex thingy in the RFCs where every node can have a different global label space and they all work together. You don't want to know the details, trust me.
Sounds horrible.
It's ugly.
I know the details already.
Nick,
right.
I'm so sorry. So yeah, from my perspective, segment routing was really easy. You just enable it and it's a bit of ISIS config and it all works. The only thing I had to do was to assign the global labels for the boxes, which was trivial because I already had the node IDs.
Yeah, mapping the label space is the, for me, it fell right into the same category as an IPAM. Like I got to figure, especially if you're doing multi-vendor SR, MPLS, there's small window of label space that works and falls under that same category that I don't want to.
No, but it's all remapped, at least if you do it with ISIS. I don't know about the BGP stuff. So single area ISIS, it works. It just works. Everything else, all bets are off.
As with most things.
Yeah.
Yeah. I mean, I could see that the VLAN stuff in particular, when you said that, I was like, there's no VLANs. But then I started thinking like, VLANs, while they may be sort of the entry level to doing, more complicated networking, when you're kind of getting your career started, every vendor does those things in a really very different way. Like, even within Cisco, you've got, the routing platforms that sort of do switching and there's like 10 steps to do it. And then you have the Catalyst platform, which is what everybody learns on, right? But then you've got MikroTik, who does it a lot like the way that the Cisco routing boxes do it. You've got Nokia that doesn't even do it, right? They support VLAN tagging, and then everything on the inside is like a MPLS circuit or whatever. And then you've got Juniper, and I mean, everybody's different, right? So I could see why that would be something that would be fairly difficult to maintain and even just create.
The first challenge was the data model. So yeah, you need some global VLAN database. Then somehow you have to assign the VLANs to the ports, and then you have to deal with access ports and the trunk ports. And then you have to deal with SVI interfaces. So, I would have to add extra virtual links into the system. The implementation itself is also a little bit tricky because I would have to, after Vagrant is done with its stuff, I would have to reconfigure the Linux bridge so that certain ports would be access ports and the other ports would be trunk ports on that bridge to which everyone is connected. So yeah, there's a lot of work to do, but eventually I might get there. Maybe I'll start with VRFs. That sounds easier.
VRFs, I mean, I was really using this as a long way to say what I always say, which is routing is way easier than switching is.
Well, you should have said layer 2 switching.
Yes, fair enough.
Yeah, but yeah, the focus of the tool has been on routing platforms and routing protocols and things around that. So, I started with, I want to have multi-access links to which the routers would be connected. And I don't care what the routers do between themselves. Yeah, probably some MPLS in the future. And then I have the edge ports. And right now there's also a Linux box you can attach to the edge ports. So you can have the workload, so you can do ping and trace route across the network without burning 8 gig of memory for it.
Yeah, that's really useful. And that's something that, at least when I started labbing, I didn't think about that, right? I was just doing everything. I'll spin up a customer router or whatever, and I'll do everything from there. But having an actual host placed off of, say, each access router, low overhead, you can do iPerfs, you can do pings, multi-protocol testing and stuff. As that's some good forethought put into there.
And it's nice to have a Linux box there too. A lot of the other virtualization platforms will use the VCPS or VPCS kind of lightweight PC emulator deal that can maybe ping and set up an IP address. But I just having a nice Linux box is so much more utilitarian than the very lightweight, but ultimately you can not do much more than ping. Kind of not as useful.
Yeah, and you can specify the Vagrant box you want to use. So you just go to Vagrant Cloud and you find the box you like. And you say, I want to have that box as that node on my network. You have to say whether it's a Linux box or not, because then I would go in and configure the default route pointing to the first hop router. That's all I would do on that box. And so if you want to have something that runs on 256 meg, that's okay. For really low-end use on Linux with libvirt, I just have to figure out the proper Docker command. So what I'd like to do is, because libvirt creates Linux bridges, and you can create a Docker network of an existing Linux bridge. It should be possible to, once the lab is up and running, start Docker and create the Docker networks and then spin up Linux containers based on whatever image you wish and connect them as the workloads to the existing network. And so you would just waste like one process per workload and not one virtual machine per workload.
I think the easiest way to do that would probably be using Mac VLAN driver in Docker, because you can tell the Mac VLAN driver in your Docker command, hey, attach to this interface, whether it's physical or a bridge. I use that a lot when
thank you.
When doing lab stuff. Yeah, there we go. That one's for free. So you mentioned Vagrant Cloud, and you can kind of point to your Vagrant images, I guess, for lack of a better word. I'm not a Vagrant expert, so pardon me if I'm using some of the wrong terms, but you can kind of point to which Vagrant image you want to use, which Vagrant VM. In general, though, another thing you mentioned was that it's not easy to get a hold of the vendors' operating systems that actually run, well, Router OS is a bad example because that actually is easy to get a hold of. But, let's say you want to run Cisco. Well, you got to, pay for a Viral license or CML or whatever they call it now. Every single vendor, it's different. Some of them, it's just a registration wall. Some of it costs actual money. Obviously those images can't be redistributed, from a licensing standpoint. So how do you kind of deal with all the just trickery around that? If I start up a fresh netsim-tools, do I have to, bring my own images? Are they included? All that fun stuff.
No, even if they would be included, I wouldn't say yes at this moment. No, you have to bring your own stuff. What I did do for both VirtualBox and libvirt is there is this website that has a gazillion recipes on how to build a Vagrant box for VirtualBox of, let's say, Cisco iOS image. And so I just included pointers to those articles, and I made sure they are on the Internet Archive just in case. So I just point people that way. From the availability standpoint, you can get iOS through CSR. It is downloadable, registration required. Nexus OS through Nexus 9300V, also registration required. Arista you can get as a VM image or as a container, yet again, registration required. Juniper VSRX3 works pretty well, yet again, registration required. Nokia released SR Linux and SRO. Well, they released SR Linux as a container that you can pull, I think, straight off Docker. SROS is built as an image inside a VM running on QEMU inside a container. So that's a little bit trickier, and I think they point you to a recipe how to do that. I have no idea how hard it is to get that box. Fortinet,
it's a pay for license. You have to buy the vSIM.
Okay.
From SROS.
Fortinet gives you a 14-day evaluation license, and then you have to rebuild the box every 14 days. Cumulus is free and downloadable from Vagrant Cloud or from Docker Hub. That's why I always use Cumulus for all my testing. There's this nice command, by the way, netlab test, which creates a 3-node topology in your selected virtualization environment, does Vagrant up or container lab up, starts the whole thing, deploys the configuration, destroys the lab, and says, cool, everything worked. So you know that, the system is set up correctly. Your boxes might still be broken. That's a different story.
Nice. That way you can just pull down some common images that work that you can just test to make sure that your environment's. That's really nice. You mentioned Container Lab. You've talked about Vagrant. You've talked about libvirt. You mind going into maybe some of how the different virtualization, I think you've referred to them as virtualization providers, work within netsim-tools?
Well, from the user perspective, they should all work the same way. So you effectively, when you put together a topology file, you just do netlab up and poof, magic happens. In the background, the topology file is created, the Ansible inventory is created, then Vagrant up or Container Lab up is executed, and then the Ansible playbooks are run to deploy configuration on the deployed devices, and then the system says, you're good to go.
So you're using Container Lab then, presumably to launch SR Linux and SROS vSIMs?
Yeah, there are things that are only available on Container Lab, and that's SR Linux and SROS. FRR as well, because I still haven't. FRR has a Debian repository, so in theory, I could just use that and start a Linux VM and download that as part of the setup process, but I'm too lazy for that. No one ever asked for it, and you should use Cumulus anyway. It includes FRR.
Yeah, no, that makes perfect sense, and I like that you're using existing tools, which we've had Roman on before to talk about Container Lab, and I'm a huge fan of the tool. But I like that you're using existing platforms that already have done some of the work, and then just kind of plumbing all that together and not reinventing the wheel on it, because that is where pain happens.
Yeah, well, it gets even better because a few people picked up the idea, and I hope I'll get his name right. Jeroen van Bimmel from Nokia. He really got interested in this. And when I mentioned that I'm not sure whether Container Lab can do multi-access networks, the next day I have a pull request where he checked the node count. And if the node count on a link is higher than 2, he would add a bridge to the Container Lab topology file and connect all the nodes to that bridge. And bam, you have multi-access networks in Container Lab in one day.
Yeah, that's awesome. I've been doing a lot of work in Container Lab. This is obviously not a Container Lab podcast episode, but I have found that this community around declarative labbing or intent-based labbing is very small, and there's not a lot of us, and we're all just kind of geeking out over doing labs more efficiently. And I've had PRs accepted to Container Lab within just days, like tons of help to have things happen. Like I think it's fun that there's this kind of revolution happening around making labs less miserable, and it's cool to me that everybody's just like, yeah, we're just doing this because we want to. It feels very maybe it's Christmas time for me, but it's it gives me the warm and fuzzies. Everybody's working together to just build cool stuff.
You just gave me the tagline for netsim-tools: making labs less miserable.
I love it.
Yeah, that's fantastic. I mean, I do like, I'm a big fan of, like Chris said, like not reinventing the wheels. And, there's a very pragmatic approach that's been taken here that I think is really useful. And I also I've kind of been poking around a little bit because I haven't had a chance to sit down and actually pull this down and start playing with it. And I was like, man, maybe I'll just see what's out there. And the documentation is quite good. So unlike most other, I would say 99% of other open source toolkits that do similar functions or kind of operate in the same realm, the documentation for this, it's in the place where you would think it would be. It's readthedocs.io. It's really complete. It's structured right. So it's easy for me, somebody who gets distracted by shiny things and squirrels to go, okay, this is exactly what I'm looking for. It's easy to find and I'm not distracted because it took me 2 seconds to grab what I needed out of it. So I think that should be commended as well.
Thank you. And if you ever feel like writing a blog post or something, just submit a pull request with a link to it. And,
God, I love
those
that.
pull requests are accepted almost immediately.
Chris is grinning. For those that can't see, because this is an audio podcast, Chris is grinning from ear to ear because he's always telling me, just do this pull request. Man, I don't want to do that. I'm not a developer. I don't want to do that. But he is grinning. I know I do it, but I complain about it loudly.
Even now, the whole thing, although I appreciate your take on documentation, the whole thing is pretty complex once you get into the nerd knobs already, and it will get more complex when we get to the VLAN and the VRF stuff. So if anyone writes a good tutorial or how to do stuff X with this tool, there's even a tutorials page in the documentation, and I'm collecting links to whatever that would be useful to the potential audience. And obviously, if you find my documentation broken or the English is a bit off, that's valuable as well. So if you just fix my grammar and submit a pull request, that's also appreciated.
That's awesome.
We are experts in poor grammar here. So I don't think that we'll be able to help. Nick or I will be able to help on that front. I think every time we publish an episode of Modem, I think somebody always says, "Oh, your blog post has this weird." What are you trying to say there?
Of course it does. I wrote it. There's probably more than one run-on sentence too. Just go look.
Yeah. No, this is really cool. Another question kind of about the tool is this something I can run on my Windows machine? Am I running it on my Mac? Do I need a remote server? What's my environment going to look like to use this tool?
Yeah. So if you're okay with VirtualBox, and there are caveats around VirtualBox, and if you can run Ansible in your environment, which Windows subsystem for Linux can do supposedly, or you just build a container with Ansible. So prerequisite is some working virtualization environment like VirtualBox, because we're talking Mac or Windows, plus Ansible. And if you have Ansible, then you obviously have Python, so we are good to go. I prefer Linux with libvirt because it spins up the virtual machines in parallel, whereas VirtualBox spins them. Vagrant driver for VirtualBox spins them up in sequence, and with Nexus OS, you can, cook a 3-course meal in the meantime, including shopping for the ingredients. So I prefer libvirt for that reason. And if you would like to have that, but you don't have a Linux box lying around, then one of the contributors wrote this nice blog post where he said, take this Vagrant file and spin it up, and you'll have a Ubuntu box. And then I added a command to the tool, netlab install, which installs libvirt and all the utilities I want to see on a Ubuntu box and Ansible. And then obviously you have to deal with the crazy world of packing Vagrant boxes, unless, of course, you're willing to work with Cumulus, in which case you're good to go. One minor remark. It looks like VirtualBox has problems with nested virtualization on Intel CPUs. So when I was running VirtualBox, Ubuntu VM with libvirt on my Mac under VirtualBox, so it's nested virtualization. You use KVM inside Linux, which is running on VirtualBox on the real hardware. It was ridiculously slow. Once I changed from VirtualBox to VMware Fusion, because I'm a Mac person for the last decade, it, sped up by like a factor of 10 at least.
Yeah, actually, running nested virtualization is the exact thing that got me to switch from VirtualBox to VMware on my Mac because it just runs horrifyingly slow. Yeah, VirtualBox, it makes me sad that it's kind of gone downhill because it was so great and free for a while. And then, I don't know, either I've outgrown it or the tools changed, I feel like.
Well, it was bought by Oracle, right?
Yeah.
And we will not go down that path, though.
We don't want Oracle's lawyers to come talk to us. They probably will. Just we've said the word. Now it's. I hear a knock on my door. Hold on.
Yeah, now they'll charge license for the tool, right?
Yeah.
Yeah.
Anyway, on AMD processors, supposedly it works just fine. So there is something in the way VirtualBox implements nested virtualization that works really well on AMD CPU because the guy who built the VM, Leo Kirchner, if I remember correctly, he was running that on his Windows machine with AMD CPU, and he said it was beautiful. And then I tried to replicate that on my Mac and was like, no.
So what I'm hearing is 2022 year of the Linux desktop.
No. I've been saying that for like 15 years now. So because someone's going to ask, does anybody tried it with Parallels? That other virtualization platform? Okay. So we don't know yet. Someone should give that a try.
From my perspective, either you write your own virtualization provider, in which case I don't care if you're using Oracle Cloud, or you have to figure out how to run Vagrant with your virtualization provider. So there are, snippets that generate Vagrant file. It's all based on templates. So you just, if you want to, run Parallels, and Parallels can run multiple virtual machines, which would be a requirement if you want to, build something from scratch with multiple nodes in your network, then you would just have to figure out what configuration file it needs and create the Jinja 2 templates that would build that configuration file based on the node and links data structure, and you're good to go.
Very nice.
You send me an email or open an issue or discussion in advance so I can guide you through the process, because not everything is documented to the level where a developer could take it and start extending the tool. But as we've learned from the SDN world, source code is the king. We don't need standards.
Right.
Worked out really well.
We lived that one.
So one pet peeve of mine with a lot of labbing platforms is doing layer 2 stuff can be a bit of a pain sometimes now. It's not as bad as it used to be. It used to always be like the old saying, like, GNS3, you can only route, you can't do any switching. And that was like the Dynamips days. And thankfully we've evolved past that. But one long-standing thing that you always have to do if you want to do spanning tree or LACP or anything like that is compile a custom kernel that, sets the Linux bridges up in a fancy way. At least for like even G, that's kind of the way you do it. You have to run a special kernel that lets you actually run spanning tree and LACP over the bridges. How does all that stuff work within netsim-tools?
Well, yet again, you can do whatever you wish. For every provider, there are 4 hooks: pre-start lab, post-start lab, pre-stop lab, post-stop lab. And I'm not sure about spanning tree, but most other stuff in Linux can be configured with special configuration flags that you set on a bridge. And for libvirt, the post-start lab would go and figure out what bridges the lab is using. It does virtual shell net list to find the actual names of the Linux bridges that are used by libvirt. And then it would set the flags on those bridges. So LLDP works out of the box. I didn't test STP or LACP.
Well, the answer is use ECMP and routing. No.
Well, no, it should work. I just didn't test it.
Yeah, fair enough.
So yeah, there are ways you can get things done with Linux bridges. And if you figure out a way to get things done with Linux bridges, you can just add those magic commands to the post-start lab hook. And the bridges will be configured the right way when Vagrant app has finished executing.
Very cool.
Obviously, only works with libvirt. You can't get into the virtual box networking. That's a black box.
Yeah.
Also, for libvirt, if you have a point-to-point link, then it's always modeled as a UDP tunnel. That was a patch that Cumulus submitted because they wanted to have, layer 2 stuff on point-to-point links. And over the UDP tunnel, it's Ethernet over UDP. So whatever this node is sending, the other node is receiving, and there's no Linux bridge in between. So all layer 2 protocols should work. I said should, not tested, on point-to-point links. Very cool.
Well, I think we're kind of coming up more or less around our time here. So I think maybe we've got time to talk about a few more things. I think one good thing to talk about would be maybe pointing us towards, how to get involved if you are interested. If I'm, new to this world of declarative labbing or intent-based labbing, or less miserable labbing, what do I do to get involved here? Where do I start? What's my entry point?
Well, there is a Python package. So you just do pip3 install netsim-tools. There is GitHub repository, github.com/ipspace/netsim-tools. There is another repository with examples, github.com/ipspace/netsim-examples with topology files. And as Nick said, all the documentation is on Read the Docs. So netsim-tools.readthedocs.io, and off you go. There's the installation guide. There are a few tutorials. I'm publishing blog posts and adding them to the tutorials. So eventually you'll figure things out. I can't build the boxes for you, though.
And I think you have a channel on... the Network to Code Slack.
Yeah, and there's a Slack channel on Network to Code Slack.
Yeah, it looks like the docs are, completed. Like I said, just looking through this, I probably could have had this spun up in the time we've been talking and had a pretty good head start on doing some things. It's pretty straightforward.
Well, as long as you would have been using Cumulus images.
Fair enough.
Yeah, that's a whole topic. And if any vendors are out here listening, please, for the love of all that is holy, make your images available. If you want people to buy your products, let them use them. Do the drug dealer model. Give us the first taste free of, iOS as a VM, or maybe don't. Maybe that's why they put it behind a paywall, is because nobody would use NXOS if they actually got to try it before it was sold to them by Cisco reps. But it's really frustrating to me that every image, the only vendor images that I know of, the only vendor images are Cumulus and SR Linux that you can easily get to without having any login, just as an anonymous person on the internet. And that's the gold standard in my book.
Yeah, anyway. Well, even if they would require login of some sort, I would understand that if I could use that login from within, let's say, Vagrant. So I could say Vagrant box add, and then point to some URL which requires login. I'm perfectly fine with that. I understand that they have to, protect their intellectual property, yada, yada, yada. But they should spend the extra 30 seconds to build the Vagrant box, and they should make it available in a hassle-free way. Pointing out, Arista, they made the right choice years ago, and they created a Vagrant box, which is 10 releases behind the current release. So, dear vendors, if you do get the message and you do decide to do the right thing and release the Vagrant box, could you please keep it current?
Yeah. Build it into your CI/CD pipelines that you have when you write code, exactly. That it just builds another box. I mean, please. Yeah. That Juniper does the same thing where they have I want to test out this new code version. Let me go download VM. Oh, wait, that's only a major release behind.
Yeah, that's very frustrating as someone who does prototyping or just anybody that wants to use it. One would expect that these tools are used internally, right? I got a soapbox. I'm standing on it real quick. Why not just, like Chris said, build that into the pipeline for building whatever the tools are that you're going to support internally? even if you have to say, oh, caveat is the documentation for this particular build may be out of date, right? The process is very likely all there. And having to deal with stuff that's old does a couple of things. One, it frustrates engineers. Two, it keeps us from testing out the newest versions without buying hardware, which almost nobody's going to do, dedicate hardware to a lab. Very few people have the budget to do that. And three, something else that I already forgot. So, there's reasons. Just do it. As I wave my hands around like it's, because I don't have to do it, right?
Yeah, from a sales and marketing standpoint, like it's a no-brainer in my opinion. I don't know. Just stop buying steak dinners and maybe put some effort into something that matters to engineers.
There is the tiny little thingy of licensing and enforcing that, because if you can run an Arista route reflector on a VM, there has to be some tools in place that sort of help them charge you for that. Maybe they should hire Oracle lawyers or something.
Well, so Chris mentioned there's the two that are real easy. MikroTik also, you can just go get it, right? You can go download the fully featured VM, they call it a CHR, that does everything that a normal box does. But they've solved the licensing. Well, first of all, buying a license for that is like eye-wateringly cheap. Like you're shocked. Your eyes are so wide, they just water because it's so inexpensive to buy one that will actually move real packets. But if you don't want to do that, you can go download one. And I think it has a limit of 1 megabit per second or 10 megabits per second or whatever. It can't be that hard to do, right? Do something like that. You don't have to deal with the licenses, and they make it upgradable. So you basically just say, oh, I want to change this or whatever. Now I can do throughput and use it as a production router, but just limit the throughput to a megabit.
Make it reboot in hours. Yeah.
I would recommend against that. That frustrates the hell out of me.
Fair. The problem with limiting the throughput is that you then install that stuff and it doesn't work the way you expect it to work. And then you say it's crap. But in reality, it's just limited to 1 megabit or 10 megabits of throughput. And you just stress test it, what you can do with 1 megabit of throughput. Well, not much. And then you blame the vendor for your own stupidity.
Yeah, I haven't run into that problem personally, but I typically know what I'm getting into. I'm just going to ping traceroute, make sure the protocols come up, and then I'm done, right? I'm not trying to oh, hang on, I got to download all my updates for my Xbox through this, through this network that I just built in a lab. So yeah, I guess, that's a risk. You're right. I could see vendors wanting to not deal with that. But at the same time, how many engineers is it going to frustrate when they don't? I would say at least there's 3 in this call right now. Yeah.
I think we can all agree they can do better. There's better ways.
Absolutely. Now, the only solution, and that would require that management actually listens to engineers, so no chance of that, would be to say, if I can't download the box to test in my lab, I will not use the thingy.
Yeah, and as I have been getting more and more into the network automation space, a big thing has been, I'm on my soapbox, has been QA testing of our network automation software. And a big part of that is being able to spin up a topology that I can use that's representative of my network so that I can actually run that in my CI/CD tests of my network code. If I can't do that, I don't want your device in my network. And that's becoming a really big thing where I'm now starting to be like, okay, this is a really cool router and it can do really fast things. But if we can't actually run our tests against it without buying, 20 racks of gear, all of a sudden I start to wonder, my small little bit of influence in the buying process goes, this is less desirable. Well, we are really right at time. I feel like we could probably talk forever complaining about vendors, or at least I could, because I love punching on vendors. It's always fun. But Ivan, thank you so much for coming on. It's such a cool tool. We'll definitely put links to all of the resources mentioned, so that y'all out there listening can find this tool and use it and start labbing in a non-miserable way. So Ivan, you want to tell us a little bit about where people can find you online, and we'll take us out.
Well, yeah, ipspace.net would be the obvious place to start. And I have to put some links to the netsim-tools somewhere in the menu or something. On Twitter, I'm still at iOS Hints because someone grabbed IPSpace a few years before I thought about that. And that guy has 2 followers, but whatever.
Very cool. Nick?
Oh, I'm around. On the Twitter at Forwarding Plane, and very infrequently these days blogging at forwardingplane.net, and of course modem.show.
Right on. Well, I'm Chris Cummings. This has been another episode of Modem. If you want to follow me on the social medias for some really poorly informed reason, you can follow me at CrankyNetman on Twitter. You can marvel at how unupdated my blog is at /64.tech, SLASSH64.tech. It's, boy, really picked a bad one.
/ like the guitarist from Guns N' Roses, and 64.net.
Yeah, exactly.
And 64 stands for NAT64, right?
Yes. NAT is a good thing. Chris Cummings is on this podcast saying NAT is our savior. And with that, thank you for listening to the Modem Podcast.
Thank you for tuning in to the Modem Podcast, where yesterday's modems are today's transponders. For more information or to request a topic, please visit modem.show.